Thank you, everybody, for joining in. Today, we are doing our second postdoctoral seminar here that is connected to the Data Science for Social Impact Research Group. Sorry, just loading something on our side, and we're very thankful for everybody for coming today for this seminar or webinar. Today we will have Dr. Idris, who will be the speaker. But before we do that, and before I completely introduce him, I wanted to ask that one of our, the sponsor for Idris's postdoc, which is APSA, and they've also been sponsoring my position as the chair of data science at the University of Pretoria, to maybe make some short remarks. I do see Gavin Cope is on here, and I hope he can unmute just for a minute or two and say hello and talk, a bit about this partnership. Thanks, Gavin.
Yeah, perfect. Thanks, Prof. I think to everyone, good morning. I'm really sort of honored to be able to join you here today, specifically on this call. Maybe just a little bit of a background. I think primarily as APSA, I think we have realized, specifically from a data perspective, data science, data engineering, Gen AI, so on, that we view these things as next generation capabilities. And very specifically, I think we've realized just how much this can not only help our organization, but also our customers, and I also think society at large. And I think that's something that we absolutely need to focus on. So this is one of the reasons we're particularly proud of our relationship and sponsorship of the University of Pretoria Data Science Chair. And I think, as we embrace these new technologies and as we expand our own internal data capability, what becomes really important is that we do engage with the likes of yourselves and communities at large, so that we start looking at what is the art of the possible and start sort of expanding our own knowledge, so we can start expanding our own circle of influence from a data perspective. So sessions like this become exceptionally important, and I think it's also a nice opportunity for the team, specifically in APSA, to have a look at something outside of their standard day-to-day work, which I think is awesome. So I think from my side, a massive thank you, Prof. Fukosi, and then obviously Dr. Idris, thank you for the time. And I'm hoping that everyone has a fantastic next hour, almost hour and a half with you guys. So thank you so much. Thank you for the time.
Okay. No, thanks, Gavin, and thanks for your continued support in this space, and do look out for everybody for more opportunities coming in the future. So today, Idris, you can switch on your camera. We have Dr. Idris. He holds a PhD from Bayero University in Kano, where he focused on using domain awareness, quality estimation, and transfer learning to optimize approaches for leveraging monolingual data to enhance machine translation in low-resource languages. Idris has led and contributed to a range of impactful projects, including developing natural language processing resources and techniques for tasks such as LLM building, sentiment analysis, emotional analysis, semantic relatedness, hate and offensive speech analysis, machine translation, name entity recognition, and sentence alignment. He actively collaborates with international research communities such as Masakane Research Foundation, LITHME, Litwi, and the Open Language Data Initiative, and has contributed to several semantic evaluation shared tasks. Lastly, Idris is passionate about mentoring students and early career researchers. We had him last week actually teach our honors natural language processing class, which is one of our biggest honors classes with about 130 students. And also integrating ethical and human-centric approaches into his work, aligning with his commitment to advancing natural language processing for social good. His research is driven by the belief that AI should be inclusive and accessible, and he strives to make significant contributions to the field while addressing the needs of underrepresented communities. So with that, we will hand it over to Idris. Just for everybody, we will do about 40 minutes or so of Idris speaking, and then I will give him a 5-minute warning before that. And then after that, there'll be Q&A. And then at that time, we'll allow people also to unmute But yeah, over to you, Idris, and then you can share your screen.
Thank you, Prof. Thank you, Gavin, for the wonderful support that made a lot of this possible. Am I audible? Can you all hear me?
Perfectly.
Okay, so thank you. So my presentation today is on some of our work that we are aimed at bridging the gap in natural language processing for low resource languages. My research interests, as Prof eloquently put them, includes translation and the general umbrella of text classification, and also building linguistic resources for low resource languages. The collaborators here include, and I'm sorry that I forgot to include APSA that funded my postdoc, but the Data Science for Social Impact Group, which is funded by APSA, Masakani, House NLP, 2 NLP, and several others that I can't mention because they are many. Most of them are based in universities. So my presentation today will entail stating the obvious, the background, which I think for anyone attending any talk of such nature, you've been hearing about problems that limits or restricts the inclusion of African languages especially, but other and several other low resource languages that are on the continent, but also in North America, in Asia, and other parts of Europe. Last year, I was doing a presentation to UNESCO, and several European languages are also complaining because the thought is any European language is just a high resource language, but a lot of those languages are complaining about the lack of resources and research into their languages. So then I will talk on 3 of our projects, of our many other projects that are in towards this endeavor to include our languages in the NLP landscape. So firstly, this image will present like a happy event that occurred, signifying an addition of a newborn baby into a family, and the husband and the wife, everyone is joyous. But then the issue here was that the text here indicated in Hausa, Mun sami karuwa. The issue here is the word karuwa here is written correctly, but meaning something entirely different. In Hausa, there is K, but there is the K with the cap, and the K with the cap represent the actual karuwa that we mean here by a new addition in the family, but K here without the cap means like a prostitute. So literally the translation is right, but in the context that we are talking about is totally wrong. And this is obtained from a translator, Google Translate. So the actual translation will have been, we got a new baby, or we got a new baby, but then it was translated to, we got prostitute. And apart from Google Translate, this also was like a very serious error that I think a lot of us encountered, especially if we are using social media platforms such as Facebook, where whatever is written, you will be asked, sometimes even overzealously by the app, that do you want to see this translation? And when you say, yeah, translate it, it gives you something that is entirely wrong. So the linguistic diversity that we are talking about in the world, there are more than 7,000 known languages based on Ethnologue in 2022, and more than 400 of these languages have more than 1 million speakers, with another 1,200 languages having more than 100,000 speakers. And a lot of these are spoken on the continent, in Asia, and around the world. More than, or almost half of these languages are considered endangered in terms, especially in terms of its use. Only 7.4% are considered institutional, meaning they are used in school to either teach or to receive lessons. In terms of technology support, a lot of these languages are not supported. If we look at this chart, in Africa, none of our languages are officially supported. The dialect of them being supported, if you will see the charts down here, are only dialect of English, especially here, English in Africa is the South African English that is supported on Google Assistant and Siri, but not any of the indigenous languages in Africa. So to understand a lot of these services, most people will have to learn one of English or French or Chinese or the rest. But if we talk now about literacy rate in terms of the ability to talk and speak in these languages, especially English, a lot of the continent, especially Africa, has like a low level of literacy. So a lot of people will not benefit from such services. So in terms of research in NLP, a lot of the languages that we are focused on are languages that are in like English or French or Chinese. Most of it are the European languages and a little in Asia. So, and a lot of our languages do not have this linguistic resource. So if we are talking about saying linguistic resource, and people will just think about data set that has been curated or annotated, or data set that has been labeled in one way or the other to enable downstream NLP tasks. But in a lot of our languages do not even have identifiable or labeled data. So if we look at this, this is Common Coral Archive, it's statistics of Common Coral Archive. Even though the statistics indicates that 30% of the world languages are African, but the Common Coral the support of African language on Common Coral is about 0.05% of all of the data that is on that is identifiable on Common Coral. So why do our languages, why are they low resource? So a lot of it is the lack of data, which I just mentioned, weak policies. A lot of countries do not even have policies on AI. Lack of compute when we have the data to be able to even deploy them or develop the model and subsequently deploy them to downstream tasks is like very, very, very difficult. We have limited coverage in multilingual models. So ChatGPT do not have official statement that is supposed the so number of African languages. Even the open source models like Llama, you do not have explicit statement that there is support for African language. So a lot of the time we try to investigate these models, even though the model authors do not even claim that they do support our own languages. So while other regions do have this big support, ours is just usually supported by grassroots movements such as Masakane, Data Science Africa, Deep Learning Indaba, Data Science for Social Impact, and the rest, but not necessarily at the government or the big corporation level. So now going into some of our work to be able to bridge this gap is the data set called Brighter. Brighter is bridging the gap in human annotated textual emotion recognition data set for 32 languages. Actually, Brighter consists of 28 languages, and then ATOMO consists of 4 languages, making 32 languages. The methodologies that were used in the creation and everything are the same, just that the 2 data sets were published in separate papers. So Brighter here consists of about 17 African languages. And this is like the most number of African languages that have been worked on a single project at this scale for a while now. So it includes several languages in South Africa, including the Xhosa and Zulu, languages in Nigeria, in Rwanda, in Mozambique, and the rest. So the data sources include social media posts. So data sets we are obtained from social media, from anonymized personal narratives or talks and speeches, because we worked with a lot of languages, so having only a single source was not possible, because a lot of other languages or other communities or other countries use either predominantly a different type of social media or the rest, while in others getting even data set in other platforms was not possible. So we used a lot of different sources in terms of Hindi and Marathi. The project coordinators had to use written human text and also give prompts to large language models to generate such data. And after such data set we are collected, there were several rounds of annotation, including many pilot annotations, where annotators were asked to read the text and determine the presence or not of emotion classes. And the emotion classes that we considered include anger, sadness, disgust, surprise, joy, and fear. These are not like, we've not exhausted all of the emotion classes, but these were the ones that we considered doable, especially within the budget of many other teams, but also but also they are applicable in many of the texts that we saw after the pilot studies. We even saw in languages such as English, the disgust class was not sufficient, as we'll see later. So the disgust class was dropped from the data set in English. So in total, we got like a lot of data sets, more than 50,000 units of unique text in these languages, these two languages that we worked on. And the data set format is in two formats. The first format is given a text, the label include, so given a text, we will have one indicating an emotion being present in the text, or 0 indicating the emotion is not present in the text. And then for 11 languages, they were also annotation for the intensity of that emotion. Why 11 languages, not the 32 languages? Because to determine the intensity of an emotion, we wanted the agreement to, or the threshold in the agreement to be more than just an emotion being in the text or not. So on the emotion intensity, we relied on 5 or more annotators annotating that, while for just the classification, we relied on 3 or more annotators. So for these 11 languages, we had at least 5 annotators that were able to label our data. In terms of the distribution, most of the data sets are joyful, neutral, sad, and to some extent surprise. For most of the languages, we found difficulty obtaining discussed class, and also fear. And the issue with labeling such data set is mostly the target is set before the annotation. So we may see we are labeling 5,000 units of text to be classified into this emotion classes and neutral. And also neutral here means this of 6 other emotions are not in there. It might be if we have more emotions, maybe the neutral class will even be as big as this, because other emotions will have been apply on the data set. So the problem here is after the annotation, then we determine which of the classes do have bigger, and then we do a sample, because we did annotation at batch level. Then when we reach the 5,000, we have to stop and then contend with the several classes that we do have. Yeah. So several experiments were conducted on this, and as I will see later, the focus was not on, say, developing models for the African languages only, because we had several other languages that are not African languages. So part of the future work, and especially our student that will be working, especially in the NLP class, will be to investigate how Afrocentric models outperform some of these more generic models that we are pre-trained mostly on high resource languages. And we found after this set of experiments that Llama, especially Llama 3.3, the 70 billion parameter version of Llama 3.3 performed relatively good. DeepSeek performed good, and Quen also performed good. Then on the cross-lingual model, because if we look at the training data here, there are some languages that we do not have training data because the number of instances that we are annotated, we are not up to us having a separate training data. If we look at the Xhosa and the Zulu, we may say we have sufficient, but going into the number of classes, number of individual classes, we couldn't say, let's say here, disgust, we only have 84 instances. Fear, we have 94 instances. So splitting this into train, dev, and test will give us not a very good split. But also, if we look at Xhosa, the disgust class, we only have 11 instances. The fear, we have 44 instances. So we decided to just include Xhosa and Zulu as zero-shot setting without training data. So we just have the evaluation data and the test data. So in most of those models, we try to implement cross-lingual multi-label, meaning taking a language that we identify as close in characteristics to the target language and using it as either a few shot or using it to train a model to do classification on the target language that do not have the training data. So in terms of the intensity, determining whether if we say there is anger in this text, is the anger like low, is it high, or is it medium, or is it, yeah. So we found that Rembat, in terms of the multilingual pre-trained models, Rembat performed better. In terms of Algerian Arabic, the performance was just worse with just 1.64. But the central theme here is for the high resource languages, which like is an open knowledge. The performance was better, but in the low resource languages, the performance was worse. So in this settings, having LLMs to predict, to classify the intensity of that emotion appeared to be better. And when we look at DeepSeek, we found the result was better. So some of the findings in this work were LLMs continue to struggle to determine perceived emotion in low resource languages. And perceived emotion, especially in terms of, let's say, banking, in terms of service delivery, determining emotion of feedback of users goes a long way into improving quality of service. So we also determined that prompting is better in English, even though we are working in languages that are in Africa, but telling the model what to do in English is a better pointer into the model understanding what it needs to do. So when I'm classifying or predicting the intensity or the emotion presence or not in a particular text involving, let's say, Hausa, it's better for me to explain that process in prompting in English rather than use Hausa to explain that and then give the model the Hausa text to do the classification. It's also that more examples, if we are in future learning, more example lead better result. And also prompt engineering, how we constructed the prompt was very important to get in the performance. Similar languages, as we say, grouping languages either based on region or based on language characteristic help in improving the languages. So this is this is Brighter. sorry, I said Afri emotion because when we started the project, it was Afri emotion. And after we finished Afri emotion, other teams indicated interest and we expanded the data set to include many other languages, up to 32 languages. So, but we started with the 17 languages. Yeah. So now AfriHate. So AfriHate is also another significant project that it's first on the continent as a work to determine what constitute hateful speech or hateful rhetoric or offensive speech or offensive rhetoric, especially on social media. A lot of the problem have been that while we know that hate, like especially hateful rhetoric, especially on social media platforms, is like an increasing phenomenon. A lot of the social media platforms were not able to accurately classify or detect the presence of such things, especially when they are written in our languages. A lot of it has been because the resources that are supposed to be used or leveraged upon to build some of these systems are not available. So, and we know that when we have like a lot of hate on social media, it may definitely translate into offline harm, like offline attacks, inciting violence, perpetuating discrimination, but also it might impact into how our elections are being run and perceived across the continent, but also all over the world. The issue with detecting hateful rhetoric is because of our linguistic diversity, cultural nuances, something that is said exactly in one language, if translated into another language, it might not constitute hate, it might just be something that might maybe at best be offensive. And also online discourse is evolving, something maybe that is discussed because there is certain event, maybe in elections or maybe some religious or politics or whatever at a particular time might be different. Maybe it has evolved over time. So the most common approaches that were used presently to detect the presence of this is searching keyword. And we all know in language, the context in which whatever is used matters. So there might be a keyword that is hateful, but maybe when used in the bigger context, it might be that someone is given an example using the word or trying to explain the word to someone, and then the algorithm will just pick it that, yeah, this is hateful, which it might not necessarily be hateful. And also the platforms rely on other users reporting this. And we all know these processes or these approaches are not adequate. So we know that natural language processing can facilitate the detection. We can adapt several language models to be able to do this. Given adequate resources, we can use transfer learning to understand context and semantics. But the problem is we don't have the resources. We don't have data sets that to do this. We don't have any data on hate speech detection on any African language when the project was started. So to start this project, we had to determine which source are we going on. We know Twitter is something that is shared across languages, and sometimes collaborative project, we have to agree upon like a single or at most maybe 2 or 3 platforms that we can focus our attention on. But we know also that several communities might have several maybe local platforms that such things might be shared. But we went with Twitter because of the easier access in getting the data set. And when we started, Twitter was free and free, especially for research purposes. So we went with Twitter instead of Facebook. The problem with Twitter is the data set. To collect the data, we don't know. Whatever you collect, you can pass in several heuristics, but we don't have support, especially on the platform, to determine whether whatever piece of text that we collect belongs to that particular language or not. So we had to deploy alternative strategies such as collecting using lexicons or keywords. We then also limit collection to particular location, thinking maybe whenever we see a text with this keyword in South Africa, let's say Zulu keyword in South Africa, it might be Zulu Zulu text, but also we had to train language identification models to filter the tweet. To collect the lexicons, we had to do crowdsourcing, introduce the project to people on social media, and ask them to please click on this link and give us a list of keywords that you find offensive or hateful, so that because we want to use them in research. And at the end of the day, we had several feedbacks. We also utilize available keywords that we are collected, especially by the Peace Tech Lab. So the data set that we are created on in this project include data sets from Nigeria, Ghana, Kenya, Morocco, Rwanda, South Africa, Algeria, and Ethiopia. Some of the data sets we are funded, but others were part of a collaborative work, especially Kinyarwanda and Swahili. A lot of people saw the project going and they were interested in participating to include their languages. And we have this map indicating the countries, but we all know that several of these languages are spoken across the border. So if we'll say we'll paint everywhere where these languages are spoken, maybe the map will have more red paint than what it has now. So to do the collection, we collect based on lexical location and social media. We do LID to filter, we anonymize the data set. The problem then was insufficient tweets, because after we started the collection, then Twitter was bought by Elon Musk. And then there is this, you have to pay to get the service. And then to get data set, you have to pay a minimum of $5,000 to just get data set for 1 month. So, and even that, you have quite a number of tweets that you can get before the month elapses. So then the annotation, so we had at least 3 annotators per language, and also we had a language lead to supervise the process. We had multiple pilots, including several workshops that one happened at EMNLP in Abu Dhabi, and the rest. We adopted definitions of what is hateful or offensive or abusive and what is normal based on literature. The data set challenges when doing adaptation, like the harmful content, were very, very, very distressing, especially to our annotators. So we had to employ several means, especially providing the first point of contact, which are the language leads, to be able to handle such instances, but also several other annotators that couldn't continue will have to be replaced and addressed. So the challenge was huge, but also imbalance. So we had instances where, yes, the keyword exists, but then the data set is not hateful. Or we said, yeah, maybe there's this particular period where election held and then there is election violence, and we did the collection based on that timeline, but also that is not hateful. So we had like a lot of imbalance that after every annotation, but we had to resample the data set. So part of also the processes that we employed into mitigating this data imbalance was some of the languages, especially Hausa and Kinyarwanda and Twi, some of the data set were manually collected, because we had several hundreds of thousands of collection from which we did sample, but to get the hateful content, at best, what you get is the offensive data. So for some of the languages, we had to utilize the language leads to do manual collection on these platforms. And also there was several rounds of pre-annotation where one annotator was asked to go through the tweet and select data sets that were either hateful or offensive or normal. And then we use that pre-annotation to build a model to serve as our sampler. So we had a high level of agreement across the number of annotators. As we said, we use at least 3 annotators per instance. and some languages use as much as 11 languages, because as I mentioned, some annotators start and then we have to drop them and the rest. So we had a lot of that as challenge. For the final data set distribution, we have a lot of abusive and then comparatively small number of hateful tweets. And also for the target, because for each piece of text that is target hateful, we ask the annotators to also label it for that to indicate whether the target of the hate is because of the gender of the person, or is it because they have disability, or is it because of ethnicity or politics or religion. And then there is the other class which we couldn't capture. And some of in the other class includes even sexual orientation, even though the number was minute and couldn't start as a class. So in a lot of it and across all of the languages, what we found most of the hate that is espoused on the data set, at least that we do have, were based on ethnicity, and then followed by politics, and then a little bit for religion, and then gender. But the continent mostly do not have a problem with disability or hating a section of the society just because of their disability, but because of ethnicity, because of their politics, and subsequently because of their religion. So we had several experiments also to determine what are the best approaches to develop models that will automatically be used to determine whether text or piece of text are hateful or rhetoric or not. So AfroXLMR was the best Pretoria language model to detect hateful content in African languages after we fine-tuned it. JEMA was the best open source LLM for hate speech detection, and GPT overall, if we are talking of LLM, both closed source and open source, GPT was the best zero-shot and few-shot detector for African languages. And I have said GPT do not have an official claim that they do support African languages, but its performance, especially on detecting hate, is very strong. Some of the ethical considerations that we reported include censorship and freedom of speech. So we totally intend our data set to be used to help sanitize social media, especially for people that are using it, not used by government or dictatorships or people with ill motive to censor people from expressing their freedom of speech. So also ensuring transparent and accountable moderation policies also by the social media platforms. And lastly, the project that I will present is Decolonized Science. I hope I have ample time to be able to
have about maybe 8 minutes.
Okay, yeah, I do have time. Thank you, Prof. So Decolonized Science is a project that was birthed because a lot of the science that we say we do, especially on the continent, we publish a lot of science, but most of these are written in English. A few might be written in Portuguese and French, but a lot of it is written in English. So to understand a lot of this concept, especially scientific concept, a person will have to understand or have a good command of the English language. This brings a lot of issues, especially inclusivity, the immediate environment. Let's say we have University of Pretoria and all of what it published. A person that is not going to University of Pretoria maybe to learn the actual science in English wouldn't know what it means if it's presented in their own native language. So the rationale for the project is we want to increase inclusivity in science, people that not necessarily understand English, but are able to understand the claims in the scientific documents that have been published, to break linguistic barrier, to enhance accessibility of research, to deepen connection between the local community and the research community, to honor our own local language, and also enrich academia and the society. So the original process of developing this resource is get the papers. Where do we get the papers? We'll see the source, the data source. But get the paper, build terminologies, because a lot of the scientific terms that we do not have equivalent in our African languages, and we are working with 6 African languages. So this will need to be part of the pipeline to develop the terminology list. And after getting the terminology list, then we give the professional translators to use those lists as guide, but to do the translation of the papers. The intended output will be the translated papers, and then the glossary terms that are then the problem that was encountered after organizing a workshop to determine the feasibility or of this as an initial methodology was that translating was quite time consuming, but also the target audience sometimes do not necessarily need to know all of the very, very huge terms or even how the science is being reported. Sometimes you may need to explain the science in a way that the layman will understand. So the collaborative workshop was organized, and afterwards the process was fine-tuned to include that after getting the paper, we translate that science to English. So we use science communicators to tone down the science as reported in the papers to generate the layman summaries. So at the end of the process of generating that science document into an English document is the layperson summary, the abstract, the glossary, and the key terms that are in the papers. And then that English version of the science paper is then given to translators to translate the layman summary, the translated abstract, and translated glossary, and then also generate new key terms if they are not already existing. So after the manual process, then automate the process into training a machine summarization system that given a paper, a scientific paper, the system is able to summarize it into a layperson summary, then that will serve as an input into a translation model that will now be able to translate into the native language. So from a paper to a layman summary, and then to the English or to the local or native language translation of that. So for data source, we used data papers on Africa Archive, on Zenedo, and on lens.org, and the target languages include languages from 3 regions on the continent. We took East Africa, Amharic and Luganda. In South Africa, Sepedi and Zulu. In West Africa, Hausa and Yoruba was taken. And after the creation, we had quite a number of new glossaries that were added that we are currently or we are not available, but now has been created. And the final data sets that were created were 230 papers with their layperson summaries and also their translations into 6 African languages. The domains include papers on agriculture, on biochemistry, biology, chemistry, computer science, engineering, geography, health, indigenous knowledge, sociology, and statistics. Yeah. So several experiments were also conducted on this after the creation of the data set to build models that are capable of doing translation. We first evaluated the capability of models at the zero-shot capabilities, meaning zero-shot, taking a model as it is and then using it to do translation, and then after fine-tuning to see how the performance improved. And as we see from the results on English, given English sentences into to be translated to our languages, XXX represent the 6 African languages, we have, after fine-tuning, the performance considerably was higher than before that. So indicating the importance of this resource. So this performance indicate If the result was not available, was not created, this is the best we can get from these several models. And now that the results have been created, this is the improvement to the quality that we do have. We also trained, because this data set are parallel across all of the languages. So we trained English to the target language to English, but also we trained models to translate between Sepedi and Zulu and Sepedi, Hausa and Zulu, Hausa and Sepedi, across all of the target languages that we worked on. But the experiments here are shown on English to the native language to English, and no language left behind is like the best model after fine-tuning. And for all of this, we have an anomaly here in Luganda, which M2M 101.2 billion parameter, but across all of the languages is either NLLB 600 million parameter and or 1.3 billion. So it's just NLLB that was the best. We also use closed source large language models. We evaluated the performance of GPT and Gemini, and we found that it was consistent across sentence level and document level, that Gemini was better translating Yoruba and Amharic, but for all other languages, the GPT model was the best. So NLP models are the best translators after fine-tuning. This is a finding. JMA was the best LLM after fine-tuning, but GPT was the best zero-shot translator. When we don't have data set, or when we have just a few examples, GPT-4 is the go-to model than JMA or Gemini. So also we experiment transparent.
I was going to say time, if you can just,
Okay, so let me just conclude. Transferring, so having the data set in the domain, the scientific domain, is better than not having or getting other data set that is out of domain. We also looked at domain level experiment and seeing how these models perform on agric, on biochemistry, on each of the domains. We also looked at the data imbalance, because for domains such as health, we had 2,600 sentences, while for chemistry, we only have 46 sentences. So we saw scaling down this data set to have a more balanced data, and how it reflect in reducing the performance of the model. So these domains benefit from each other. E.g., if we see chemistry, even though the data set was not reduced, but the performance reduced, because the number of sentences in the other domains also was decreased. So also at document level, we saw that Gemini was the best model on Amharic and Yoruba and across the shots, while GPT-4 was better on the rest. The most recurring problems were wrong translation, especially by GPT and by Llama, but there are several omissions where a particular word, if it is not understood by the model, it's omitted from the document translation. And this gave birth to the UP Decolonized Science, Decolonized Research Project, where we are replicating similar project in collaboration with the lab and the University of Pretoria Library. We've finished the pilot process. We are developing the models for this. And thank you for listening.
Yeah, okay, thank you. Thanks, Idris. I think, yes, it was a lot to try and pack in to the period. And I think it's also a great, a diversity of the areas that you're very passionate about. I think maybe on one side, that a question that will come from me just to kick off before people come in. If you have a question, you can just raise your hand on Zoom, and then I will acknowledge you. But a big part is thinking about in these projects, there's a couple of like technical steps that have to come in, and you're dealing with a lot of languages, a lot of different places where the data is coming from. Maybe any advice for practitioners on how to deal with the product, more the experiment and research management, especially when you're working at this type of scale? Like how do you basically keep yourself in a part where you understand that or you and the team are going in the right direction?
Yeah, so a lot of it, thank you for the question. A lot of it first, like the first motivation is to be able to have these resources first, and then the technical aspect of it definitely will come, and especially is at the end of it. A lot of this has been made possible because of the extensive collaboration that we do have. Most of our teams do have several experts that deals with several processes. So for each workshop that I say here, there are teams that are assigned developing this workshop and then determining what will be discussed. Its generality is yes, discussed and agreed in a meeting, but then there is the data set team, there is the technical team that does the baseline experiments. This also usually is discussed and agreed in the generic, but then there are separate responsibilities. But without collaboration, this research wouldn't have been made possible.
Okay, thank you. I think I'm just going to go with first Ranesh's question, and then we'll go with Coyote. So there's a question that, did I understand that OpenAI R1 model was able to reason and translate from English to other African languages? Was this compatible? Was this comparative done with O1 model from DeepSeek? How much effort does it take to fine tune these models, and how much improvement? It's all in the text, and maybe Idris, it might be better to just stop sharing your screen for now. Yeah.
Okay.
Yeah. Oh, sorry.
Okay.
Yeah. If you can answer maybe that question for now.
Yeah. So our experiment did not include those models that were referenced. The models that we did, especially in translation, were Gemini 1.5 Flash model and GPT-4o. So we did not include that. So we don't have any specific finding on the suitability or maybe the superiority of those models that were referenced. On the DeepSeek and on the DeepSeek, we used it on the the emotion dataset, which is the brighter dataset, and its performance was very good, especially in predicting the intensity of emotions in the 10 or 11 target languages that we experimented with, compared to the other models.
Okay, cool. Thanks, Coyote.
Thanks a lot, Idris, for the interesting talk. My first question is, how did you work around maybe some of the ethical issues? Because I see you listed a number of social media that you get your data set from. So how did you manage to gain access to these data sets? That's the first question. And my second question is on the Decolonize Science project. At test time, did you do your testing on the lay version of the English text or on the original English text? Yeah, thanks.
Okay, should I answer or should I wait for other questions maybe?
I think you can go ahead.
Okay, so on the ethical issues, most of it comes from the Afri-Emotion, or I like calling it Afri-Emotion because that was the beginning of the project, but also the Afri-Hate project. So getting the data set, a lot of the social media platforms allow access to the data set for research purposes, but also sharing the data set, you have to follow guidelines. Twitter does have that. You have to remove any personally identifiable information, meaning you have to replace mentions, you have to replace handles, you have to remove website references and the rest. So we did that to handle all personally identifiable information. For also getting some of those data, like data sets from Reddit, like a lot of these collections were already done, so they are available. And also during the AfriSenti project, it also helped us have these several DOMs that were reused in projects such as AfriHate and Afri-Emotion. For the other languages that were not part of AfriSenti, that's where we found it very difficult to do the collection, because of the because of the bottleneck that was put in after the acquiring of Twitter. So for also as an ethical consideration, if I may include, in addition to obtaining the data, was also the process of doing the annotation. And annotation, especially in computational social science, can be very, very, very difficult. Not even talking about Afri-hate, but even Afri-emotion. There are emotions also that might be distressing also. Maybe sadness emotion is distressing to others, maybe surprise, because people can be overexcited by saying things. So a lot of those things we are managed, especially at the lower level. Each project or each language is assigned a language coordinator that is in charge of doing the recruitment, is in charge of doing all of the ethical guidance, especially to the annotators. We are in charge of the overall training and then provision of the guidelines on handling emotions and the rest. So that for the decolonized science project, the data set was, yes, original paper, but original paper was not translated directly. So first the layperson summary was generated, and then the translation of the layperson summary. So at the test time, but also the current data set, it's you have the original data set and the layperson summary that makes up the summarization data set, but then the layperson summary and then the translation makes up the machine translation data set. So we use the layperson summary translation to do the model development and the rest here.
Okay, I will go to a text question before going to Siani. Marian says, thanks for the presentation and amazing work. Peace Tech Lab have published hate speech lexicons for African countries like Sudan and Ethiopia. Were any of these tools utilized in the Afri-Hate project?
Yes, I think in the presentation I said we use Peace Tech Lab lexicons, but the lexicons were very, very few. I think the Hausa lexicons, even the Hausa lexicons that we are tagged, I think there was no Hausa lexicon, but there's the Nigerian lexicon or Nigerian language lexicon. Even at that, you find, I think you hardly find 5 lexicons in Hausa. Yeah, so there were like just far too low what we need. So we had to employ other means, especially crowdsourcing, to get sufficient lexicons that we are used to do collection for the data set that will be annotated eventually.
Okay, thanks. Siani.
Oh. Okay, thank you for the, am I audible? I think so.
Yes.
Okay, thank you for the great presentation. I have one question and an advice. From your presentation, you mentioned that the methods you use for detecting hate speech, you used the most common approach, and one was keyword matching, where you used lexicons and so forth. I just wanted to ask, can you explain more about it? How is it done? And what is it more about? And my second question, or rather advice, as someone who is actively working on misinformation detection, I am envious of the work that has been done on data set of Afri-Hate. So what advice can you give for someone who probably would want to start up a misinformation data set? What challenges have you faced? What advice can you give? Yeah.
Okay, so on the keyword one, I think in my presentation, what I stated was not our own methodology, but part of the current methodologies that were utilized by social media platforms to determine hate. So part of it is, we said that is a problem because it doesn't take into consideration the context in which those keywords are being used. So developing models will definitely be more accurate, or will serve a more accurate way of detecting what is hate speech when those words are used to denote hate speech and the rest. So in terms of the how, I think it's whenever a keyword that is deemed hateful is present in a text, that potentially flagged that text in its entirety to be considered potentially as hateful content, even though part of the problem will be that not all presence of keywords that are, and also part of the experience that we learned is when you do the collection, yes, you rely on keywords to do collection, but when the eventual annotation is done, you find out that those keywords, even though they are present, but they are not hateful. So those are the things that also was part of our experience. On the advice, I think hate speech and misinformation can be construed as similar tasks, but I think they are different. Because in terms of misinformation and disinformation, you need to have facts to be able to disprove or confirm whatever piece of information that is being claimed to be online. So, but in terms of hate speech is at best, if we even say explainable hate speech is what constitutes hate speech, yeah, what is a text hateful or not? What is the target of the hate speech? Are they targeted at people of a particular religion or a particular sexual orientation or a particular ethnicity or a particular political affiliation or the rest? So that at best is, and maybe also determining maybe the timeline in which they are most propagated or most disseminated, especially because this is tied usually to, let's say, when there is an election, you find out the spike of this, or when maybe, as the case in Nigeria, when when a particular region is in power, the opposite region will now be hateful towards the other region. And when the power shift change, and then you will see the switch. So, but with regards to this information, I think even in terms of creating the data set, it's a little bit different because you need to have the data set, but also you have to have a list of facts that support or disprove that piece of information. And there is, I think, a lot of resources, especially on the high resource language. Even the same eval this year, there was a shared task on misinformation. In misinformation, and you can find several templates on how to create such particular data that will serve our low resource languages. Yeah.
Thanks. Another one on the text. With low resource morphologically rich languages, would it be costly and time consuming to develop a model that can be able to capture these morphemes, since major models are English centric?
Yeah, so there is this like each language is unique in its own way, but also there are languages that are very difficult. So taking Yoruba, for example, some of our findings, especially in the translation project, was we had very, very low performance compared to all of the other languages, even Amharic. Amharic is written in Ethiopian script. I couldn't pronounce it right, but all other languages are written in Latin script. But then the Yoruba language do have the diacritics, where the presence or absence of the diacritic will change the meaning of any particular text or document that you are working on. So even the models find it especially difficult to generate the right word at the right context that is supposed to be. So evaluating that with the diacritics and without the diacritics, you find like a very substantial influence in the performance. So when you remove the diacritic, it's easier for the model to just predict the word. When there is the diacritic, then the decision will have to be what type of the word, what version of the word should be in that context during the generation by the large language models. So enabling or perfecting the support of these languages, especially the morphologically rich and also languages such as Yoruba. In this sense, the models to understand them, the models to have a sufficient amount of them in their vocabulary will go a long way into improving the performances on African low resource languages.
Okay, thanks. There's more questions on the text. Okay, one is, since funding may be a challenge, how do you plan on getting resources to cover all of Africa? And this is a tough question. And then the second one, that's from Nefi, I think. And then the second question, just because of time, a lot of the languages represented are widely spoken on the continent. Do you plan to include more underrepresented native African languages? And do you think it will be significantly more difficult to do this with time, given the erasure, given globalization?
Yeah, so as much as there is globalization, we also want our mini globalization on the continent. So having, say, a language, there is this language where I was born in Nigeria, in Jos, called TV, but I've never seen any resource, any textual resource that meaningfully represent that language. And even in Jos, where I was born, there are more than 50 languages spoken, because it's this like a conglomerate of a lot of people that were there just to do business when there was mining there. So to have that sufficiently represented, the main bottleneck is the absence of collaboration, especially in those languages. So to work on a language, you either need a person that will volunteer, because a lot of the work that we do are volunteer work, especially on Masakani. Yeah, so a lot of the work are volunteer work. A few of them are sponsored, paid data generation endeavors, but also even paid, I think the effort in getting those people to be able to lead a language, to do, there is this particular language, Oromo, that we are working on in Ethiopia. There was a time when even getting the sufficient number of annotators to label in that language was proven to be difficult. There was a time in Ethiopia when the internet was even not available, it was shut down. So to even get the contact with the annotators. So there are a lot of challenges that, including several other languages in Africa, is like a very, very good endeavor. It's something that we will want to do, but the effort and the resources that needs to be expended in that is very, very, very big. And some of the times the funders will want, particularly you have to work on these languages. So that's why I said when we started working, thinking, yeah, we'll work on 10 languages, and that was the proposal. But we included 7 other African languages out of the funding for those other languages. And then collaboration enabled us to scale to 32 other languages. So a lot of this rely on the presence or absence of collaboration, especially on the continent.
Okay, I think the last one, you'll be like in 30 seconds. Would voice-to-text or AI assisted transcription tools be more effective in reducing the time required to collect text? And that's from Ida. And then from Shalane, in the context of decolonization, who should own and control these linguistic data sets? Should communities have a say in how their languages are digitized? I know, again, you're solving world problems here. So, so
yeah,
you have like a minute and then I have to close, yeah.
Yeah, I have my own perspective, but I think especially with the voice-to-text or ASR, I think our lab is working on this very big, ambitious project on developing the capacity of even these models to be able to recognize our languages or even be able to transcribe our languages. And Professor Vukosi will do a very good job, if maybe after I finish answering, to give maybe 1 or 2 sentences on that project. But also in terms of intellectual property, there is a good work that is being done by the Data Science Law Lab in the university, also in collaboration with our lab, especially Professor Vukosi, on trying to see who owns these resources. When they are owned, if there are benefits accrued from these resources, how are they judiciously used to benefit their resources? So it all starts and ends with the copyrights that we have, the privacy laws, the ownership laws that we do have. And Professor Vukosi also is in a very good state to give 1 or 2 words on ownership.
Okay. Yeah, I think on that, in just 30 seconds, yeah, there's a lot, both for Ida and Shalane, that has to be discussed in those spaces. We do hope in the next number of engagements. I think thank you for bringing those questions up. There are some work there is some work that has come in from the past from the Data Science Law Lab through Prof. Chijioke Okori that you can look at on our YouTube. Just to check the previous seminars covering that, and then we like, you know, it's worthwhile to understand these problems. And yes, it should be for communities to be able to choose what their destiny is supposed to be, and that's the thing we really champion. And on the ASR one, yes, we have a project called the Next Voices Project that we're hoping in the next 3 months or so, we will be able to share the first major data sets in these spaces. We have a sample that you can find on Zenodo, but it'll be 3,000 hours of, for example, in South African speech for 7 languages. So we are also looking forward to seeing what the community is going to do with that data. Yeah, I think with that, we are really thankful for Idris's presentation. It was really, I think, a lot that we had to cover within that period. That's why we thought like, let's just take it a few more minutes in this case, so that we can just get all those questions out. I have shared the link to the YouTube for Dr. Okori's talk from the past, and I think it'll be worthwhile to look at that. So thank you. We look forward. We do have another, the last of our postdoctoral seminars, which will happen next week. It will be at it will start about 2 hours later than this one. So I look forward to then engaging with everybody there. Thank you and enjoy the rest of your day.
Thank you.